I have one more question. On the same figure, we're going to look at just point X and point Y. So what were the coordinates of point X?
Negative 7, 1.
Negative 7, 1. And Y?
Negative 1, 4.
Negative 1, 4. How about I will ask you to find where on the directed line segment XY would lie a point, let's say point A, that will partition the line segment in a ratio 2 to 1. Again, we're on line segment XY, and it's a directed line segment. And we're looking for point A, which would partition it in a ratio 2 to 1. Let's go ahead and work this out, and we'll share in just a few minutes. Let's find a good place to stop. We'll have Sally share their strategy about finding the point on a directed line segment.
Yeah, so we're looking at the slope. So just have the parts. So it's like the stair steps. So there's 2 stair steps there and there's 1 there. And so that to me made sense. I have no idea what they did. They could tell you.
Well, let's talk about it. Then let's talk about what you did. Would you like to add anything to Sally's
Yes,
comments?
please tell me how you did it.
What I did is I found the distance between the x coordinates and the absolute value. So, and then I found 2/3 of that because there are 3 parts and we wanted a 2 to 1 ratio, so 2 parts. And then I added that to the x1 coordinate. And then I did the same for the y. I found the distance between the y's and then found 2/3 of that and added it to the y coordinate. And then that's what put me at negative 3, 3.
And why did you like the slope strategy?
I mean, I just saw it whenever, because
Visual.
mine was off a little. And so I was like, well, I knew it was off because it looked wrong. And I thought, well, if those little stairs, you know, there's 2 and 1, my kids might see that.
So this is something the students can do if they forget the formula, right? And things like that, which we should not even go to the formula until we do visual strategy and common sense strategy, like Sally said, right? I think your group also started at the same place with, would you mind coming up front also showing your picture, because it reminds me of Sally's.
We did a visual approach as well, but ours was a little bit different. We did have to know, we didn't have to know 3 parts right now. We just needed to know we're starting with X, and it's got to go 2 to 1. So here's kind of how we approached it. We kind of looked at it as a vertical and a horizontal piece, okay? So we know we've got 2 to 1, and if you want to know 3 parts, I have 1, 2, 3 units. So this is kind of how we have done it. We start from here, we go up 1, up 2, and if I go up to where I know I'm going to end and come back 1, there's my 2 to 1. And so if I look at it, it works out perfectly. It's an even, you know, if it's a fractional amount, if we have extra spaces, this would take it another level. And then I just kind of look across and I can see where I'm supposed to be on Y. And just to verify, let's do the same thing across the horizontal part. So over 2, come back 1. Over 2, come back 1, and this is where I should be on X. So I know it's 1, 2, it's at negative 3, 3. And that's another visual approach. And again, that works out perfectly when there's an even amount of things. And if there's extra space, then you have to do the fractional amounts within. You have to know that this is 3 parts.
And of course, there is, the formula that we refer to sometimes. By the way, there are two different types of formula that are given in our updated frameworks now. If you look at the framework tasks that address the standard GPE 6, which is partition in the line segment, you will find a weighted average formula and just a formula that we had taught in the past. We have two formulas right here. What do you think? Leah?
Wow, it's very daunting, and why? It's so much easier to understand there, and if students were to see that, especially initially, I can see where that will be overwhelming.
Paige?
The first time I saw that, it was overwhelming, and it took me a while. And I love this, the visual first, going from that and understanding that actually makes sense after I had the visual.
That is the key.
But I still, like the visual.
That is the key. This makes sense after the visual. The visual is what makes the formulas make sense, right? So there's really nothing technically wrong with using the formulas as long as
It makes sense.
the students understand what they mean and they make sense. Yes, Jennifer?
I had the same conversation with 7th grade teachers about always jump into the formula when they were actually it was with proportions, jump into the algorithm right away. The students don't understand why the algorithm works. But if you first make them do something conceptually, then after they understand the concept, then show them how that concept fits into the algorithm. Then they appreciate the algorithm because they understand the value of the algorithm.
Yes.
So it's always better, in any type of problem solving, that if they get the concept, they understand conceptually, then they take that and they see how it fits into the algorithm, or they see the value of the algorithm.
And then they can explain why the algorithm works, right? That makes it complex and
Then the algorithm doesn't necessarily have to be memorized.
correct.
They understand why it works. They can rederive that algorithm.
Absolutely. And they will not, students will not be memorizing. They will be learning math and making sense of math. What would be good here is ask our students, where do the formulas come from? Now that they know how to find a point on a line segment, could we ask them to make sense of this formula?
I was just going to say also, as a learner, it would be helpful for me to take the visual and then say, what if we didn't actually know those coordinates, and then give it specific values that where X represents a variable. And then from there derive and get
the
to
formula.
that, versus seeing that and not really understanding the bridge between the visual and that.
Absolutely. And I'm so glad you mentioned that, because it's always a great strategy to then take out the numbers, take out the numerical values, and just give kids just the variables X and Y, and especially in geometry with the distance and perimeter and area. There are so many different things we can do if we just simply say, hi, this is X1, Y sub 1, this is X sub 2, this is Y sub 2. What do you do with that? How do you find it? Kids could actually derive this, you're right, if they have a solid understanding of the process of the concept beforehand. All right, this is the original formula that we had in our frameworks as the standard was first introduced. Our updated frameworks now have the weighted averages formula, which looks maybe a little bit easier, right?
Yes, it does.
Now, how do you think, how can we transition from this part to this part? Do you think that if we perform simply algebraic computations here, right, if we multiply distributed A over the difference between x2 and x1, and then added x1, which the common denominator will be A plus B, so once we compute all this, we'll actually come up with that. So those are really equivalent expressions right here. This is just a simpler maybe way to write it if we do want to go with the formula, right? Well, thank you so much for this discussion, but because I really don't know what would happen if we just gave this to students and say, hey, This is our formula. What do you think will happen?
Shut down.
They'll shut down. But oh my gosh, I'm not doing that. I'm done.